Okay, all right. I've managed to delete. Can I have all the videos on, please? I cannot see anyone. Okay. Okay, so the previous homework we'll discuss first and then we'll move on. Was that homework 3, I guess, right? Or was it homework 4? I forget. Homework 3?
3.
Homework 3, right? Okay. All right, let me bring it up as well here. Okay. All right, let's start from the first one. Kunsh, do you want to start proceedings? How did you do the first one? What did you get?
Yeah, I got 5/2.
5:2. Okay.
5/2. Yeah.
Okay. All right. 5/2, 5:2, same thing. Apurva, same answer or?
Yeah, 5:2.
Okay. Just for completeness, should we quickly do it for everyone? Fairly basic question, right? So this is regular polygon N. It has N sides. And then polygon Q has, by doubling the number of sides. So Q has 2n number of sides. So this has 2n sides. And it has 6 times as many diagonals. Okay. So first of all, just to be very clear, regular polygon means, one sec, I want to make sure the recording is on. Yeah. Okay. Regular polygon means the sides and the angles both must match. So in a triangle, it's anyway the same thing, right? If you say that all the sides are matching, it's equilateral. You don't have to explicitly say the angles are also equal. Whereas in any quadrilateral, after 3 sides, you'll have to tell that. For example, if I say I have a four-sided quadrilateral with all the sides equal, it can be a rhombus where all the angles need not be equal. Or if I say all the angles are equal, it need not be that the sides are equal. So neither the rectangle nor the rhombus is a regular quadrilateral, only a square is. Therefore, it's important to mention that the sides need to be equal as well as the angles need to be equal. For something to be regular, that's what the definition is. Okay, just a side note. Now, we also know the number of diagonals is n into n-3 divided by 2. Okay, Vihan, can you tell me why the number of diagonals is n into n-3 by 2 for an n-sided polygon?
Yeah, so basically how it works is that when hello.
Yes, I can hear you, Vihan. Go ahead.
Yeah, so basically when you have let's say you have 4 sides.
Yeah.
So if you have 4 sides.
Yes, 4 sides. Okay, I've drawn more sides. That's fine. Go ahead. Yeah. Vihan, you're breaking up. Okay, we lost Vihan. Avinash, you want to explain why the number of diagonals is n into n-3 by 2?
So I don't really know why. I just knew that formula.
Okay, Rohan, can you explain, please?
So, sir, the divided by 2 is the double counting.
Okay.
And then, so the reason it's n-3 is because if you draw a hexagon, for example, there are 3 points that you cannot take if you select 1 point, which is that point itself and the 2 points next to it to form a diagonal. So that's why it's, and there are n sides, so it's n times n-3 by 2.
Exactly, right? So I've drawn a heptagon in this case. If I take any one node, any one vertex, I cannot draw a diagonal to 5, I cannot draw a diagonal to 3, I cannot draw a diagonal to 4, right? If I'm looking from 4's perspective. Therefore, for an n-sided polygon, from a given vertex, I can draw only to 7 minus 3, which is the number n-3 in general vertices. But each vertex counts n-3. And then a diagonal. Yes, yes.
Yeah, I think I lagged out. I was just saying that you can't in a shape, you can't draw like a diagonal to the ones right next to the side.
Exactly. And to itself.
So that, yeah, to itself, yeah.
Yeah, so 3 gets ruled out, therefore n to n-3. And then like Rohan was saying at the beginning, every diagonal gets counted twice. For example, if I draw a diagonal from 1 to 3, 1 will count in its quota, 3 will also count in its quota. To avoid double counting, divide by 2. Okay, so in this case, n into n-3 by 2 is the number of diagonals for polygon P. And then for polygon Q, the number of sides is 2n. So 2n into 2n minus 3, 2n into 2n minus 3 divide by 2. Okay, now these two are related by the fact that this is 6 times, right? This is 6 times. The number of diagonals is 6 times. Now it's just simply solving this, right? So 2 gets cancelled. 6n gets cancelled with 3. So I have 3n minus 9 equal to 2n minus 3. So n equal to 6 and 2n equal to 12. Okay, and we can quickly verify for a 6-sided polygon, it has 6 into 3 divided by 2, which is 9 diagonals. And for a 12-sided polygon, you have 12 into 9 divided by 2, which is 6 into 9, 54 diagonals. And sure enough, it's increased by 6 times. Okay, so we verified. But what is the question? Ratio of internal angle in Q to external angle in P. So be careful, internal here and external here, and Q first and then later P. So always be mindful of how the question can be twisted around in many different ways. Okay, so let's do internal for Q. So for any n-sided polygon, the sum of internal angles is 180 into n minus 2. This is the sum. Okay, and if it's regular, then I can divide by n to find each. Otherwise, the meaning of each does not mean anything, right? If they are all different. But in a regular, they are all different. In a regular polygon, they're all same angles. Therefore, each angle is 180 by n minus 2. So in this case, in Q, it's n is, I'm saying n here, but really it's 2n, right? So I'll just say m, just to be clear, where m-sided polygon. Okay. So in our case, m is 12. So I don't get confused between this n and that n. So it's 12-sided polygon. So each angle is whatever this is, 150, I think. Okay. Whereas coming back to the other polygon, so this is each internal in Q. This is Q internal. Now let's do P external. Sum of all external angles in any sided polygon. If it's 73-sided polygon also, the sum of external angles will only be 360. It's independent of n. And therefore, each of them will be 360 by n. In our case, n is 6. So it is 60. So it's 50, 150 is to 60, which is indeed 5 is to 2. Yeah, straightforward question, but just to make sure all the basic formulas are covered. Okay, that was good. Question 2. Okay, Rohan, you want to take question 2?
So I got 1:3.
For the ratio of the two areas for the first part?
Oh, no, that I
No, I
got 1:9.
got 9,
1:9. 1:9 for the first part. For the second part, I got 1:3.
Okay. Okay. One is, so we have to just be careful. Is it the smaller to bigger or bigger to
So
smaller?
1 is to 9 and then 3 is
For
to 1.
B, it should be 3
Oh,
is to
I
1.
was just giving any order. I didn't write in the order.
Okay, fine. I mean, for now it's okay, but obviously in an exam situation, you have to be careful. Yeah, this is right.
So-
Just, yes, go ahead.
So I got 1:9, and then in the second part, I got 3:4.
3 is to 4. Huh. Okay, all right. Let's discuss just to be clear. So these are all two similar objects, right? So what have I told? If there are two objects which are exactly similar, I mean, not exactly similar. If they're similar, it means exactly same shape and size alone is different. So when this happens, let's say these two are similar. There's one big amoeba and small amoeba, let's say, whatever, right? So if there's some scale factor, what is the scale factor? I can take two corresponding points in the two figures, and that gives the scale factor, that ratio. It can be anything as long as its correspondence is there. So by that same logic, these two are some random heptagons. I've given non-regular just to make sure that people don't assume anything, right? But thing that matters is AC does correspond to AC is A to C is like 2 apart. P to R is also 2 apart. Right? It's similar, it's given. So the scale factor is 3 is to 1. So this is the first figure and this is the second figure. Obviously, I've not drawn a heptagon here, but let's say this is the heptagon A, B, C, D, E, F, G. And this is the other one, P, Q, blah, blah, blah. Okay. Okay. So the ratio of the areas would be K square is to 1. So if the scale factor is K is to 1, any linear ratio will be in the same ratio as K is to 1. Any area will be in the ratio K square is to 1 square. Okay, this is any area, and any volume will be K cubed is to 1 cube. For example, I can make up a 3-dimensional question based on this, and then that volume ratio will be K cubed is to 1. So for example, I can have a big man and a small boy, right? If I give the ratio of the two heights, and then I can ask the ratio of the two weights or masses. So mass is essentially proportional to volume, right? Assuming the human body density is the same, irrespective of whether you're an adult or a child. And therefore, you can use the same as the volume, K cubed is to 1 cube, something like that. Okay, so in this case, we are talking about two ratios of areas, and it's smaller to bigger. Therefore, ordering matters, 1 is to 9. And in this case, who got 3 is to 4? Shivank, was that you? Or If I hit
No,
something.
so it was me. So
Yeah,
the way
go ahead.
I did it was I said that like the area, like the radius of a circumcircle is A into B into C over 4 times the area of the triangle, right?
Yeah, correct. So the radius of the circumcircle is for any three-sided, I mean, any triangle, it's ABC by 4 delta. Correct. You're right. Yes.
And then I said that for like the other, like heptagon,
Okay.
it'll be like
Let's say
3
PQR by 4 delta.
Yeah,
Okay.
yeah. So for the other one, it'll just be like 3 into 3 into 3. So you get 9 in the numerator and then 36 in the denominator because the area is 9 times. So I got 27 over 36.
No, but the problem
But
is,
it's
yeah, go ahead.
but
Yes.
that is correct, but it's 3 upon 4 is to 1 by 4, right? Because
The 4 is
um,
common in both, right?
yeah, but even if it's common, it's 1 by 4. So if the area of that one is whatever 9 times the area of that one, so it'll become 36
Yeah,
delta
yeah.
is to 4 delta, and then on top it'll be ABC, and then there will be 3 times 3 times 3 times ABC. So it'll be 1 by 4 is to 3 by 4. So it'll be 1 is to 3.
So that's the mistake I made. I didn't take
Yeah,
the
one
1 by
step.
4 into
Yeah.
account.
Yeah. So you don't even have to look at all that because that's what exactly the point, right? You don't, these are all common numbers. All we have to do is we are talking about some perimeter of something and an equivalent perimeter in the other one. That's all matters. It's a ratio of lengths. And therefore, it has to be just k is to 1. But if at all you have to do this also, let's say A, B, C, and PQ are here. So they are all 3 times. Let's say this is 3 times P, this is 3 times Q, and this is 3 times R instead of P, Q, and R. So that's a ratio of 27. And I'm using a ratio of 2 areas here. This area will be 3 square times the other area, right? So as we saw in the previous part. So this is, sorry, this is not 3 square. This is just 1 time. So the smaller one area is delta 2, let's say. The bigger one will be 3 square times delta 2. So effectively, all of this delta 2, 4, everything will get cancelled. P, Q, R, everything will get cancelled. You have a volume ratio at the top, which is ABC, and area ratio at the bottom, which is 9. And therefore, the ratio is just 3:1. Make sense, Apurva? Okay, cool. Question 2, that was. Question 3. Okay, Apurva, did you do question 3?
Yes, so I did question 3.
Okay.
So
First,
should I give you the answer for all the subparts?
no, let's go each part at a time. Yeah, let's start with the first part. What did you?
7, minus 5.
7, minus 5. Does anyone's answers match with this? Avinash, did you get the same?
Yes, sir.
Okay. Apurva, please explain what you did. Sorry, I heard some other voice.
So fourth quadrant is which quadrant?
Okay. I thought all of you know this. So this is 1 and we go in anti-clockwise. So it's 1, 2, 3, and 4.
Yeah, I did that only. Oh, okay. I see my mistake. Okay, so I got -7, minus 5, thinking that 3 was the fourth quadrant. I don't know why.
Okay.
No, I
just
think I can see why. No, I knew that was the fourth quadrant, but in my head, I thought it would be minus. So yeah.
Oh, but if suppose it's this quadrant, it would not even work, right? Because the circle has to go like this. Yeah, there's no chance of the circle being in the third quadrant.
Yeah, hitting the 2 and 10. Yeah, I didn't think about
right?
that.
It cannot hit two
Yeah.
vertically opposite
Yeah.
quadrants. Just 1 second, guys. I'll get some water. 1 second. Okay. All right. I'm back. Yeah. So Apurva, can you tell me what you did to get the 7, minus 5?
Yes, sir.
Yeah.
So basically, first I do like the
Okay.
the thing, and then after that, so I marked the 2 points 2 and 12 on the x-axis, and I realized that the x coordinate of the center of the circle has to be the midpoint between 2 and 12, which is 7.
Correct. Okay. 1 second. Let me just draw this for you. Okay. So this is the circle. Okay, and then I'll extend the x-axis or y-axis also. Yeah, go ahead, please. So this is 2 and this is 12.
Well,
Okay, and the center has to be, the x-coordinate has to match the average of these two, which is 7.
Yeah.
Okay, and yeah, intuitively that's what makes sense. But why is it so?
So I guess because like since it's cutting at 2 points, the radius, like the center of the circle, if you divide the circle into 2 parts, like
Yeah.
vertically, then it'll come like that, right?
Correct. It is right. I mean, just to be very clear. So if I draw a perpendicular bisector from the center, right? I mean, it passes through, I mean, the perpendicular from the center to any chord will bisect it. And exactly what we want, right? So it passes through 7 comma something. Yes, go on, please. So you don't know the y coordinate now. Okay.
Yeah. So after that, what I did was, like they've also given us that there are 2 points on the x-axis, which is separated by the y-axis. Like in the circle cuts the y-axis at 2 points, which are separated by 2
2
by
units. Okay.
separated by 2. Yeah.
Okay. So what are you calling them?
We can call so anything. I actually haven't labeled them in my
Okay. Fine. Okay. All right. Fine. Okay. Go ahead, please.
Yeah. So then after that, like from the center, I drew like a so perpendicular to the line that you've already drawn to the y-axis. I drew like a line that's parallel to the x-axis from 7 to CD.
Okay. All right.
Yeah. And then basically I made the like, so we also have that since they're separated by 2 points, right? So on each side from the point where that radius, like that line intersects CD, from there to D, from E to D, it's 1, and from E to C, it's also 1.
Yes. Agreed.
And you have that E to the center, E to P is 7 because, right?
Yeah. This is 7. Yeah.
So then using Pythagoras theorem, you can get the radius.
Radius is square root of 50, right? 7 square plus 1
Yeah.
square. Okay. So far, so good. Continue.
And once you have the radius, I think I use distance formula and then just got it.
Distance formula. So yeah. So very good so far. So this is 5, and then the radius is. This is also root 50, right?
Yeah.
And therefore, I can find. Let's call this point as f, right? So root 50 is the hypotenuse. 5 is one side, therefore this also has to be 5. 5 square plus
Yeah,
1
you can
square
use anything. I actually don't remember what I did. But I think I used distance only. But this is also This,
okay, so this is 5, and therefore we conclude that this point is -5. Is that what it is?
Yeah, it is
Negative 5, and therefore this is -4, and therefore this is -6. Yeah. Okay. Wonderful. Did anyone do something different?
So I used a circle formula.
Which formula for circle?
The
The intersection of chords?
No. I use the x minus h the whole square plus y minus k the whole square is equal to r square.
Sure, but how did you apply that in this case?
I subbed in values.
But what value do you have though?
I subbed in the 2 points where it intersects the x-axis, and I took w as the coordinate for D and w plus 2 as the coordinate for C, and I subbed in and I got the answers.
Okay, wonderful. Okay, so multiple ways, and I'm going to call out another way. So just to recap what Rohan did. So an equation of a circle, we did this I think in the last class, right? X minus h whole square plus y minus k whole square equal to r square gives the formula for a circle with any center h comma k and any radius r, right? And that's because if a random point x comma y is here, then by distance formula, this is x minus h and this is y minus k. So by Pythagoras theorem, we are saying x minus h whole square plus y minus k whole square equal to r square. Now what he has done is he's applied the points 2 comma 0. So he'll say, sorry. So he doesn't know the coordinates of the, or did you say the x coordinate is 7? You already went with the x coordinate as 7? Or you didn't do that?
No, I did everything in this using.
Okay, all right. That's also fine. Another is Apurva's method clear to everyone? Kunal, you're okay? And you got the same answer, Kunal? Okay. Another way, I told you this last class. If I have 2 chords which are intersecting, so I have AB, and let's say this is O for origin. Okay. So AB is a chord and CD is a chord, and both of them are intersecting at O. You can see they're externally intersecting, right? So we saw the theorem AO times OB should be CO times OD. Okay. So we saw this last time, right? This theorem. So AO times OB is what? 2 into 12, which is 24. And CO and OD are 2 lengths which are apart by 2 units, right? CD is 2 more than CO. So we need to find 2 numbers whose product is 24 and was separated by 2 units. So it's 4, 6. That's how you get this is -4 and -6 very quickly also. Does it make sense, Apurva? Another short way. Okay, good. Okay, so that answers the A part. Kunal, you want to pick up the B part? The circle is divided into 4 equal parts. Find the perimeter of each quarter circle. Fairly straightforward, right? Kunal.
Yeah, so just like from the first part only we can
From the first part, we found the radius is 5√2, right? 5√50, which is 5√2.
yeah,
And then what do we do after that?
like we have to find the circumference of the circle and divide by 4.
No, that's exactly why I've given this question. Why won't that give the correct answer? Bihan,
So
Because it doesn't count the lines, right?
exactly, right? Yeah, right. So it's not just 2 pi r divided by 4. Yes. Plus also you have to add the 2 r's, right? When you find
And
the
then you have to account for the overlap that might be there, right?
no overlap. We are just
Oh
talking
no,
about the
because it's
perimeter,
just
right? Just the perimeter. So this is 2 pi r by 4 that everyone will do, but many people forget to add the 2r, the r here and the r here. Does it make sense, Kunal? When you ask the perimeter for a quarter circle, it's not 1/4 the perimeter of the full circle. Okay, all right. Vihan, third part, C part. If the equilateral triangle tangentially encloses the circle, find its area.
So then if you have, so basically you draw a triangle outside the circle.
What did you get? Let's check if your answer matches with others. What is the value that you got?
So I
Didn't
got
simplify
like
it.
sorry?
No, you didn't simplify it, or
No, I wasn't I didn't say I didn't simplify it. I got some random value, so I just didn't do it after that.
okay. Can you describe what to do? That's fine. Can you describe what to do?
So if a equilateral triangle is enclosing a circle tangentially, firstly you have to draw a triangle outside the circle, around the circle.
Yeah.
So basically once you draw the triangle,
Vihan, you're breaking up. Okay. Vihan, you're breaking up. I'll pass it on to someone else. Shivank, can you finish this C part?
So I wasn't able to get the C part even. I got some weird answer. I
Okay.
don't know.
Okay. Vihan, is this better? You're after switching off the video? No. Okay. Anahat, you want to finish this C part? Anahat, are you there? My God, why are so many people facing issues? Avinash,
yes, sir.
what did you do?
So
For the C part?
150√3.
150√3. Apurva is also nodding his head. Okay.
Yeah.
Avinash, please describe. What did you do?
So we had learned, I think, in some class that r is equal to delta upon s. So radius
good.
of the in circle will be area of the triangle upon semi-perimeter. So
Correct.
area
Correct.
of an equilateral triangle is √3/4 into side square,
Very good.
and semi-perimeter will be 1.5 side.
Exactly. 3/2x.
So,
And then using
we
this,
know
we
the
can find.
radius is √50.
Exactly. Yes. And from this, it
So
comes
you
out. Yeah.
just equate it and you get the side, and then you'll sub it in that first formula and you'll get the area.
Perfect. And given two answers
Yes,
are
I got the
matching.
same.
Yeah. Multiple people answers are matching. Very good. That's good. Okay. D part. Let's see who hasn't answered this one. Who has done this? Kunsh, were you able to do the D part, tangent to the circle?
No, sir.
As in,
I
you don't
got
have
stuck
time?
in A, sir.
Oh, you got
I
stuck in
got
A
stuck
part
in-
itself.
Yeah.
Okay. All right. Apurva, what did you get?
Yeah. So for the perimeter of the circle of the triangle, I got 5√2 plus 2√6 plus √74.
Oh,
With
slow. 5√2 plus 2√6 plus √74. Yeah.
with m equal to 5, n equal to 2, a equal to 2, b equal to 6, and c equal to 74.
One small mistake. M is given to be less than n. So you should say m is 2.
Oh,
and-
yeah.
right,
Yeah,
which is-
yeah.
Right, this is n, this is n.
Yeah.
Okay.
So it was
Yes.
it.
Did anyone else match the same answer? Rohan, did you get the same thing?
So I didn't have time to do it.
Okay. It's
I
fairly
skipped this and then went to
Yeah.
the 4 and 5 and did that.
okay. Apurva, can you describe this? How did you do this one? So there is a
Uh,
tangent. Yeah.
Yeah, so a tangent to the circle from the origin what touches, yeah. So first what I did was one side has to be the radius of the circle.
Okay. Let me draw another picture here so that it's clear to everyone. So this is. Okay. So this is 2 and this is 3. Okay. So I'll just draw a tangent from this. Okay. So this is O, and what have I labeled? Tangent from the origin touches the circle at T, and this is P. Okay. Go on. Now yours. Okay. Yeah. Go ahead, please.
So one side just has to be the radius of the circle.
Which is PT is the radius of the circle, which we have. Correct.
Yes. Okay. So then after that, you can use Pythagoras theorem to
Exactly.
find the rest.
Exactly. So P is 7, minus 5, and O is just origin, which is 0, 0. Therefore, OP, so I'll just finish it off here. OP is, by distance formula, it's 7 minus 0 whole square. I'm just doing it explicitly. Minus 5 minus 0 whole square, just so that everyone is aware of the distance formula, which is square root of 7 square plus 5 square, which is root 74. Now, you know this is root 74, and you know this is 5 root 2 or root 50. And therefore, by Pythagoras theorem, I can find OT, right? 74 minus 50 is 24. So square root of 24. And therefore,
And-
the perimeter, yeah.
Yeah. And then after that, once you get it, you just need to factorize it correctly in the form of what he wants.
Perfect. Yeah. So root 24 plus root 74 plus root 50. Okay. Right. And when I say A, B, C do not have a perfect square as a factor other than 1, that means right now 50 has a perfect square, which is a factor, namely 25. That means you have to take 25 out and bring it as 5 root 2. Similarly, 24 has 4, which is a perfect square and it's a factor. Another way of saying simplify it. So all this extra hi-fi stuff is just a simple way, or rather complicated way of saying simplify. Get out of the roots anything that you can get out and simplify. That's all. So now once you get it in this form, because just to read again, A, B, C do not have any perfect square as a factor, because if they did have a perfect square, that can come out of the root. That's the first thing. And I've given M1 less than M less than N, because if you have to identify M and N, there are two expressions like this, A root B types, right? Or P root Q, whatever. So I should know which is M and which is N. So to make that identification, I said the smaller one is M. Okay, so fairly straightforward, but again, the question can seem a little daunting with so many variables and square roots and all that, perfect square, right? But if you break it down, well done, Apurva. Did anyone else get the same answer? Avinash, did you? Sana, how about you?
So I got this same thing.
Got the same answer. Okay, sounds good. Sana, how about you so far following along, or did you do any of them? Not able to hear you, Sana. You're unmuted, but I cannot hear you.
So I got almost the same answer. I just realized I made a calculation mistake, so I just corrected it.
Okay, all right, sure. Sana, are you able to speak up something?
So I couldn't do it. So
Okay, as in couldn't do it, as in couldn't get time to do it, or tried it but couldn't get it? Which of the two?
I couldn't solve. I couldn't open. I couldn't.
You couldn't
solve
get
it.
time. Yeah. Okay, that's fine. Whatever it is, just be bold, right? You couldn't get time to solving it. Okay. Yeah. So I've been through this multiple times, not just you, like multiple people, right? Take homework seriously, guys. I mean, looks like today from the participation, looks like all of you have given a decent shot. Okay. All right. If you have signed up for this, that means you're supposed to spend time. That's all I can say. Okay. All right. Let's go on to the next one. Question 4, Avinash. Question 4.
Yeah. Didn't we just discuss 4 or what do we just discuss?
There was question 3, I think. Question 4 is altitude. Ym is the altitude to the hypotenuse.
1 second. Okay. Wait, I'm not sure if I did this. Wait, 1 second. So I got so find the side lengths of XYZ, right? So
Mhm.
I got root 5.
Mhm.
Then I got root 15 upon root 2 and 5 upon root 2.
Okay. Did anyone else's answer match with this?
Sir, I got all except one side as the same. Wait, I think he's
Yeah.
I've written it differently. Like I've written it a little differently. I've simplified it so that the root denominator is not in the root.
Okay, then this will be root 30 upon 2.
Yeah,
And
I
this
got
will be
that.
5 root 2 upon 2.
Yeah, so same
Which is-
answer I got. So
Same
I
answer.
simplified
I
it.
got all the sides except the last one.
Okay, all right.
Yeah,
Avinash, can
even
you,
I rationalized it.
No. I got that.
okay, Avinash, can you
Yeah.
describe what you did? Let me just draw a diagram. So this is YZ. Okay, I'll just draw.
So is that a right angle or?
This
Yeah.
is the upper wala is right angle.
Okay.
Sorry. Let me just let me just label this. So which is the, so let's say Y is this thing, and he says
Yeah.
YM. I say the sides YMZ. Which is the smaller one? YMZ. So this is Z and this is X. Okay, and then let me just draw this vertical line from Y to ZX. Okay.
Okay.
And this is M, right?
Hmm.
Where it intersects. Okay, continue, please go ahead.
Yes. So there are 3 prime numbers, right? And so I just found 2, 3, and 5 to be working because 2 is even, right? So
No, before we go to the prime numbers, these 3 are similar. Okay,
Yeah.
so what happens? So you can write some ratios out here, right?
yes. So I didn't do that. I just
Okay.
went.
Okay. I'll let you go in your own style. The sides of Y and Z are square roots of 3 consecutive prime numbers. So why is it root 2, root 3, and root 5?
So because all odd numbers will multiply to form a sorry, wait. All odd numbers add to form a even number. So
What do you
that's why
Be more clear. All odd numbers
will add the sum of of 2 odd numbers will be an even number.
correct. Yes, and therefore, if I go
therefore,
for any
like,
sequence
5 square
after
plus
this,
3, 5 square, 3 square, and 2 square, something like that will work. But
rather-
anything after that will not work if there are no other even prime numbers.
exactly.
There's
Yes,
also the fact that you have to find 3 prime numbers basically that in which 2 of them add to the third. And if you go past 2, 3, 5, it becomes way too large for it to even conceivably work.
not just way too large, but to Avinash's point, you'll have, let's say there are root P and root Q and root R, where P, Q, and R are prime numbers beyond 2. Let's say P is more than 2. Let's say this is the sequence, right? Then P, Q, and R, all 3 have to be odd. So when I do P plus Q, when I square them for Pythagoras theorem,
You will not get
odd plus odd will be even, right? R cannot be even because R is prime, right? Therefore, the only set that will work will be 2, 3, and 5. Yes. Continue. Now it's labeling of which is the smaller
So,
one is.
I think ZM is 2 in your diagram. I labeled it differently, but ZM will be root 2, YM will be root 3, and the hypotenuse is root 5.
Even in your diagram, that's how it has to be, because
No,
YMZ
I
is
think I didn't draw a diagram like this. I made it slightly different, so that's why the root 2 and root 3 I think got flipped. The bigger line I drew.
maybe in this question it does not make a difference, but you have to, even in your diagram, MZ has to be the smallest.
Okay.
No, you don't have to say okay to me. I mean, in the sense, if you get something different, then that means something wrong you're doing, because YMZ is given to be the smallest. So the picture has to be something like this, right? How can you get YM as root? How can you get ZM as root 3 and YM as root 2? That's not possible.
Yes.
Okay, you check your diagram anyway. Okay, now that you have root 2, root 3, and root 5, continue. Go ahead, please.
Oh, okay, sir. So the now we know that YZM is similar to YXM, right?
Okay, yeah.
So-
So all the 3 triangles are similar. Yes. Okay.
Yeah. So because YZM is similar to, sorry, not YMX. Sorry, I was saying YZM is similar to YZX, the big.
No, that is also true. All
Yeah.
the 3 triangles are similar to each other. There are 3
Yes, sir.
sets of similar triangles.
Yes, sir. But I just directly went to the big triangle.
Big triangle. Yes.
So firstly, YZ will stay the same as root 5.
Okay. Yes.
And then you'll have the and YZ is the smallest side in the triangle YZX.
Correct.
And the smallest side in YZM is root 2. So
Yes.
ratio of smallest sides is root 5 to root 2. So it will be 5:2 will be the ratio
Exactly.
of the smallest sides.
Exactly. So just so that everyone else is on the same page, this is YMZ. Let's say this is YZX or XYZ, whatever it is. So in the triangle YMZ, the smallest is root 2, the medium is root 3, the largest is root 5. And in the other triangle YZX, or
This-
x, y, z, whatever it is. The smallest is √5. So √5 comes here. And the medium is xy. And the largest xz. And now just based on ratios, you can find xy and xz. Right? So, so xy, let's do it again. So xy would be √5 into √3
upon
by √2, which is √15 upon √2, which is correct. And then xz would be √5 into √5 upon √2, which is 5 upon √2. That's also correct. Wonderfully done. Okay. And looks like few others answers also matched. Rohan, you're completely in agreement finally, or did you find your mistake, or there was none?
No, it was correct only. I just couldn't read my handwriting properly.
Okay. Abhihan, yours as well, right? Matched completely.
So
Your answer also matched, you said. Bihan?
yeah, but so I did with a different, like a slightly different method.
Okay.
So
I'll come to you, Apurva, but I was asking Bihan for a second. I thought he had something that was matching or not matching, Bihan.
No, I got the same as.
You got the
what-
same answer. Okay.
Yeah.
Apurva, what did you do? How did you do differently?
so since ym is perpendicular to zx and
Yeah.
angle zyx is a right angle, I use the property of right, like such a figure where yz square is equal to zm into zx,
That is
yx square is equal to xm into xz. and
excellent. That is coming from similarities only.
Yeah.
So did I derive that relation last class or something?
Yeah.
Okay. Yes.
Yeah,
Yeah, sure. That's perfect. And so what he's telling, that's very important. That actually comes from similarity of triangles. So let's recap that. So in fact, let me remove all of these values so that I can state that relation. So in fact, I'll just so that you guys are not biased by, I'll just relabel them as A, B, C, D and all that. Okay, A, B, C, and D. So in any right angle triangle, suppose I have an altitude from the 90-degree to the hypotenuse, there are three geometric means. Geometric means what? So what is geometric mean? So suppose I have 3 x and 12, and x is the geometric mean of 3 and 12. That means x square should be 3 into 12, which means x is 6. That's what geometric mean means. In other words, 3 by 6 should be 6 by 12. What is a number I can insert where the ratio will be 3 by x should match x by 12. So x square is 3 by 12. So by that, there are three geometric means here. AD square, AD, which is the perpendicular from the, will be the geometric mean of BD and DC. So AD is the geometric mean of BD and DC. AB square. So, okay, AD is easy to understand, right? The perpendicular is the geometric mean of this guy and this guy. AB square is the geometric mean of the projection, the shadow that falls. Let's say they have sun shining up from the top here. Where does the shadow of the AB fall? It falls on BD.
AD. Oh, BD.
No, shadow on the ground is BD. BD times the full length, which is BC. Similarly, analogously, for AC, the shadow falls on CD. So AC square will be CD times the entire BC. Okay. So, but all of this come from similarity of triangles, Apurva, right? If for example, I can write AC by CD is BC by AC, something like, if you rearrange them, it's all similarities fundamentally. Okay, wonderful, guys. Nice. That was question 4. Question 5 was also simple, just trapezium and 30, 60, 90 and all that. Kunal, what did you get? Question 5.
Sir, that sum, like I did it, but the calculation was getting too much. I'll tell you what I did. So
There'll be √2s and √3s, but not like too difficult to maneuver. You'll have a bunch of √2s and √3s. Yes, but continue, Kunal.
yeah, so
Don't be
like
scared by. In fact, I explicitly say you can leave your answer in terms of √2 and √3. Okay, continue.
I think maybe I made some error, maybe.
Okay, no, that's fine. You would get some expression, right? It might be ugly, but call out your expression. What did you get?
Yeah, okay. So like I just took it like I made the trapezium, and then I took the height along the can you hear me, sir?
Yes, I can hear you. Yes.
Yeah, okay. So then like I made that height like of the trapezium next to the, like, to make it a right angle triangle at that point, like, you know
Okay.
what I mean?
No, I don't. There are 2 trapeziums here. I don't know which one you're talking about. Do you have a final
Both of
expression
them.
to call out, which we can check with others?
I used like trigonometry.
All that is fine, Kunal. What is your final answer that we can just verify with others in the
Oh no,
class?
so I didn't get the
You
answer.
don't have a final answer. Okay,
No,
sounds
sir.
good. We'll do it. Rohan, do you have a final answer on this?
I got 2 plus root 3 is 2 root 2 plus 2.
2 plus root 3 is 2 root 2 plus 2. Okay. Does anyone's match?
So
Yes,
I
Calculation?
I
Avinash
got
is
an
saying yes.
alternate answer. I'm not sure. I
Okay.
don't think it's right because there's
Okay.
no root 2 in it, but I got 3 is to root 3 plus 2.
3 is to root 3 plus 2.
Yeah, but there's no
it-
root 2, so I'm
Yeah,
not sure
it's
if
weird.
the
There
right
must
one.
be a root 2 for sure. So very unlikely this is very likely this is wrong. But let's check, right? Okay, let's check. So there are two trapeziums. So fundamentally it's easy. We all know this A, B, C, D. So this is given to be this. And then okay, let's finish the blue trapezium first. I've given this to be 45, right? This is 45 degrees. So let's call this as X. So this is X, this is X, right? If I drop a perpendicular here, this is also X. And by 45, 45, 90, this is X by root 2, and this is X by root 2. We are okay on this. Multiple times we have done this, right? In a 45, 45, 90, the ratio is 1:1 root 2. So if the hypotenuse is X, the base and the perpendicular would be X by root 2. So this is also X by root 2. This is also X by root 2. So if I look at what is the area of a trapezium, it's height into average of the two bases, right? That's the area of a trapezium. So in this case, the height is X by root 2. And the upper base is just X, and the bottom base is X plus X by root 2 plus X by root 2. So 2 times X by root 2, which is root 2 times X. Kunal, you're following me along so far, right? And I'll check
Yeah.
what you did using trigonometry. You should still get the same answer. Let's check where you've done a mistake. If you used a trigonometry, you should still get the same thing. Okay, now here, same thing. So this is X, this is also X, this is also X. This is 30 degrees. Therefore, by 30, 60, 90, X being the hypotenuse, this has to be X by 2. The height has to be X by 2. And this has to be X by 2 times root 3. This has to be X by 2 times root 3. So similarly, the area would be height, which is X by 2, into average of the two bases. The upper base is X. The bottom base is X plus X root 3 by 2 appearing twice. So X root 3. Okay. So now let's look at the ratio of these two, right? Obviously, X square can come outside. And then what do I have inside? I have 2 plus root 2. Okay. I'll just change the color here so that it's neutral. I don't want. Okay. So both I'll put in black. So this is X square into 2 plus root 2 upon 2 root 2 is to X square into 2 plus root 3 upon 2 into 2. Okay, so I'll cancel X square and 2. I'll cancel X square and 2. I'll cancel the 2 with the root 2. I'll cross multiply. So this becomes 2 root 2 plus 2 on this side. And on this side, it becomes 2 plus root 3. Yes, the ratio matches with what Rohan called out. Only thing is, I'm not sure in which order I've asked. That you guys can check. A, B, C, D is to P, Q, R, S. So I think my ordering is right. Rohan,
the order will be the other way around.
other way. Yeah, Rohan, the order that Rohan called out is ulta, right? And you have to bear in mind this, Rohan, because I'm sure there'll be choices where it'll be ulta in the paper, right? So always don't trivialize this last step is very important, right? After getting all this, if you mess up, then it's very sad. Okay, but anyway, well done. Any
So-
doubts, guys? Yeah.
Yeah. So I figured out the mistake I made. Like, I took the ratio of the 45, 45, 90 triangle wrong. So instead of 1:1 root 2 in my calculations, I wrote it as 1:2 in some place, in a place. So then I got it
Okay.
wrong.
Which is why there's no root 2 at all in your picture. Okay, sounds good. Kunal, what is the trigonometry mistake? Did you find a mistake or do you want me to find it out for you?
It was not a mistake with that. Like I actually just made a calculation mistake. I did something very stupid. Like it's not wrong, but instead of taking instead of like I didn't use the 1:1 root 2 like ratio for the sides. I actually used trigonometry to find them. I took it as X and did that. And then instead of like once I got 45 and 30 ka side, the side of that, instead of just like taking the other side as the complementary angle of that, I I used Pythagoras theorem, so the calculation became very bad.
Okay. All right. Yeah. So bottom line, when there's 30, 60, 90 or 45, 45, 90, there's no need to use trigonometry. You can use trigonometry. It'll still give the same answer, but try to keep things as simple as possible, right? So remember these ratios again, 1 is to root 3 is to 2 for 30, 60, 90, and 1 is to 1 is to root 2 for 45, 45, 90. Okay, sounds good. Anahat, all good so far? I didn't know, I called out your name somewhere in between, but I think you could not unmute. You're okay? I cannot hear you as usual, Anahat. You are unmuted. Yeah, now your mic is lower. Yes.
Yeah,
all
sorry.
good.
Yeah, I'm all good. I didn't hear my name, so I just.
Oh,
didn't
yeah, but your answers are all matching with this. You were able to attempt the full thing? Or...
Yeah, I didn't get one of the questions, but I figured out the answer.
Okay, all right. So let's move on to like more basics on algebra. So we did, there was a few topics that we wanted to cover in algebra, right? So I didn't, fractions, percentages, and ratios, all that we finished. Equalities, inequalities we did. Quadratics we did. Functions. Okay, arithmetic progression and geometric progression. So we didn't touch on that, right? So Apurva, did we cover arithmetic and geometric progression? I don't think so.
No, sir, I don't think we did.
Okay, yeah. So let's do AP. AP stands for arithmetic progression. Okay, arithmetic progression. So arithmetic progression is nothing but you start with any one number and then you uniformly increase by the same quantity. So this is an arithmetic progression, right? So typically I can start with any number A and I can have some common difference D. So this is A plus D, this is A plus 2D, and so on. So suppose I'll have to go for the fifth term, right? So how do I find the fifth term? You start off with some value, and then to reach the fifth term, you need 4 hops. To reach the fifth term, you can see the diagrammatically, you need 4 hops, and each hop is of size 3 in this case. So more generally, you're starting off with some number A. To find the nth term, I'll need n minus 1 hops, and each hop will be of size D, right? So A plus n minus 1 times D, this gives the formula for the nth term. So nth term is typically denoted as un. Sometimes people call it tn. Sometimes people call it a suffix n. These are all suffixes, not products. So this is denoted to denote the nth term. Okay, so I can find the 77th term without actually writing out the sequence. Okay, so the other thing people want to do typically in arithmetic progression is sum of all terms till, let's say, the 22nd term, right? So for example, a typical thing could be, I started reading a book, I read 4 pages first day, 7 pages next day, 10 pages third day, and so on. I keep increasing my reading. And then let's say the book has 1,000 pages. Right? How many days will it take for me to finish the book? Something like that, which means we need to add the terms in an arithmetic progression. So how do we do that? So let's take the simple example. Suppose it's 4, 7, 10, 13, and 16. Okay, suppose I want to find S suffix 5, which is sum of the first 5 terms. I can also write the same sum in a reverse order by saying 16 first, 13 next, 10, 7, and 4. So if I do this, and I can do a small trick. Suppose I add these two, then what do I get? I get 16 plus 4 is 20, 13 plus 7 is 20, 10 plus 10 is 20, 20, 20. And it's not coincidental. It's all the same 20 because of the way the arithmetic progression is uniformly spaced apart. So the first term and the last term compensate for the second and the semi-last and all that, right? So all of those sums will be, so S5 is just how many pairs there are. There are 5 terms essentially, which is why 5 pairs. And each pair adding up to 20, and then therefore divide by 2 will give me a S5, right? Let's take the same thing and extend it for Sn. So if I do the same thing for any general n, let's say I want to find the sum of n terms. So instead of 5, it's n now. And then there'll be dividing by 2 because there'll be 2 times Sn, just like the previous step was 2 times S5. Now, how did I get 20? I got 20 by adding the very first term and the very last term, right? 4 plus 16 was the first 20. So, and everything else was the same 20, right? So I can do the same thing. 20 was a combination of the first term, which is A, and the nth term, which is A plus n minus 1 times D. Okay, so this gives the sum of the n terms of an arithmetic progression. I intentionally don't want to write this as 2a plus n-1 times d. I want to keep it as a separately because this stands for the first term. And I want to keep this a separately because this stands for the last term or the nth term. So it's the average of the first and the last term times n, right? So that gives the sum of n terms in an arithmetic progression. Okay, any questions so far? Sana, you're okay completely? Sana, I cannot see your face, baby. Just can you shift your monitor so that I can see your full face? Same with Kunal also, right? Okay. All right. All okay, guys? Kunal, you're okay? Okay. Next. So similar to arithmetic progression, the other important progression that you need to know is geometric progression. Geometric progression. Okay. Geometric progression is where the ratio between successive terms is same. So 2, 6, 80, 54, like 54 times 3 is 162. So just like you have additive hops, you have multiplicative hops in this example, times 3 times 3 times 3 times 3, right? So how do I find the fifth term? So let's say I want to find the fifth term in a geometric progression. I started with the first term. I keep multiplying 3, 3, 3, 3. How many times I multiply? 5 minus 1 times, because the number of hops is 1 less than the term I'm seeking, right? So similarly, if I have to generalize this to reach an nth term for a geometric progression that starts with a, and each successive term is multiplied by r, right? So I'll start with some a, and then you keep multiplying several r's. How many r's? To reach the nth term, you need n minus
Minus
1
one.
multiplications. Yeah, sorry, someone had a question? Vihan, was that you?
No.
Oh, okay. Okay, so a times r power n minus 1. That's the nth term. Okay, and similarly, we want to find, let's say, the sum of the, so by the way, let's quickly check. 2 times 81, right? 2 times 3 power 4, indeed 162. So we've validated that this works. Okay, so similar to arithmetic progression, you would want to do the sum of n terms in a geometric progressions. How do we do that? So let's say the sum I'm seeking. So I'll directly do for Sn. So Sn is a plus ar square all the way till ar power n minus 1. Okay, now there's a small trick you can do. Suppose I multiply this whole by r. So I say r times Sn. Okay, then the first term is ar, second term is ar square, and so on. But I'll write it shifted. So I'll start writing from here. I'll write the first ar here, and then I'll write the ar square here. And then the penultimate term will be ar power n minus 1. And the last term will be ar power n, which is this guy getting multiplied by r. Right? Now you can guess what I'm going to do. I'm just going to subtract. It's like a telescopic cancellation, right? So if I do Sn times 1 minus r, then all the terms will cancel off 0, 0, 0, 0, except the very first will prevail and the very last will prevail with a minus sign here, right? And therefore, in conclusion, what do I have Sn as? I have Sn as a times 1 minus r power n upon 1 minus r. Okay. Alternatively, I can write it as a times r power n minus 1 upon r minus 1. That's also fine, right? Typically, when r is smaller than 1, people use the left one. When r is bigger than 1, let's say r is 3, then rather than deal with negative number, I'll go with r power n minus 1 by r minus 1. But either way, negative will get cancelled. So it does not matter. Both forms are equivalent only. Okay. Now, in geometric progression, one extra nice feature. So for example, if I'm looking at a geometric progression like 16, 8, 4, 2, 1, half, and so on. So I can see the starting term is 16 and the common ratio is half. It's always the second by the first, third by the second, and so on, latter by the former. The common ratio is half, not 2, right, in this case. Now, suppose I want to find the 1000th term, sum till 1000th term. So what will this formula give me? It will give me 16 times 1 minus half power 1000 upon 1 minus half. Right. Now, if I look at this half power 1000, it's a very, very tiny quantity, right? Half power 1000 is almost 0, right? In fact, it will have later when you do logarithms, you can, okay, in fact, let me just ask around. Half power 1000 will have how many zeros after the decimal point? Suppose I have to write 0.0000 Can anyone take a guess, or can anyone tell me how many zeros will there be? Rohan, any guesses?
1000.
1000 zeros? That'll be, if it's 10 power 1000, it'll be 1000 zeros. It's only 2 power 1000, right? So it has to be fewer than 1000 zeros, right? Do you agree, Apurva?
Yeah. So, but like you only want half to the power 1000, right?
Correct. So which is a bigger quantity than 1 by 10 to the power 1000. 1 by 10 to the power of 1000 will have whatever 1000 zeros or 999 zeros. Aage piche thoda 1, that's fine. But half power 1000 is a much bigger number, right? It won't have 1000
Yeah.
zeros after the decimal. It will have fewer.
So
How
the
many?
reason I'm saying that is average, like you can take half as 0.5, right? And then
Correct.
0.5 into 0.5 will give you 2, and then like 0.5 square is 0.25, and then
Correct. 0.5 square is 0.25.
oh, you're talking about the number of zeros. You're not talking
Number
about
of
the
zeros
number
after the decimal point. I just want to
Okay.
illustrate how small this quantity is. That's all.
Okay.
Okay. Anahat, any guesses? Half power 1000 will have how many zeros after the decimal point? Or anyone for that matter.
After the okay.
After, oh, yeah, after the decimal point, yes. You can
Yeah,
again just approximately, yes.
yeah, about 300.
Okay, why 300?
I just guessed.
Matlab, why not 400? Why not 200? कुछ तो logic होना चाहिए ना?
2 power 3 is near 10, I guess. I don't know. I
Uh,
didn't really use a lot of logic. I just said.
okay,
For
Kunal,
997.
997 is Rohan's guess. 300 is Anahat's guess. Kunal, you had something?
I also think 300.
Why 300?
Because like I don't know, I was guessing, but when we take half to the power 2, it comes 1 by 4, which is 0.25. So that doesn't have a 0. Half to the power 3 is 1 by 8, like 0.1, that's 0.125. That also doesn't have a 0. Then half to the power 4, that has a 0, because like
Okay, so basically your logic is it took 3 hops for you to get to the first 0,
yeah,
and therefore when you do 1000 there are 300 hops roughly.
yeah,
That's a good intuition. Yes, the answer is around 300 only. So basically we can 2 power 3 is 8, I agree, but 8 is still far away from 10. A better approximation is 2 power 10, which is 1024, which is fairly close to 1000. So we can say
So
2
can you
power,
repeat the question you had asked earlier?
no, I was asking 2 power, or rather half power 1000 is a
Yeah.
very tiny number, we all agree. I wanted to know how many zeros does it have after the decimal point? Does it have 76 zeros or 1000 zeros or 300 zeros and all that? So people had different answers there.
Okay.
Right? So, and as a response to that question, I'm saying 2 power 3 is 8, right? But 8 is still significantly away from 10, right? Because relatively speaking, 8 is like whatever 20% or 25% off from 10, right? So, but to first approximation, what Kunal was saying is every 3 times you raise 2, so 2 power 3, it takes 3 attempts to get the first 0. And therefore, when you do 1000 times, you'll need approximately 1/3 the number of 1000, right? So a better approximation is 2 power 10, which is 1024, is much closer to 0. Therefore, 2 power 10, which is 1024, is much closer to 1000, right? It's only 2% off from 1000, right? So I can write 2 power 1000, therefore, as 2 power 10 whole power 100, which is approximately 10 power 3 whole power 100, which is 10 power 300. And therefore, the reciprocal of this will have approximately 300 zeros after the decimal point. That, of course, you have to be careful. Is it 300 or 299 or 301? That we can figure out. But approximately, it is 300 zeros. Does it make sense? Okay. But my point was, yeah, two points. One is you should know how to approximate. That was this. My point was, this is approximately, therefore, 16 by 1 minus half. So when I'm doing S till 1000 terms, right, it's approximately A by 1 minus R. So the n does not even matter beyond a certain point. So we can talk about S infinity. If I go for sum till infinite terms, it'll be A by 1 minus R in a geometric progression. Right? Does it make sense? Okay. Now, note that R can be negative also. For example, I can have a sequence where I have 24 minus 12, 6 minus 3, right, 1.5 and so on. right? As long as in modulus R is less than 1, which means, yeah, numerically, if it's less than 1. In other words, if R lies between 1 and -1, then I can apply this S infinity formula. But if R is numerically bigger than 1, for example, suppose I have 24 minus 48, 96 minus 192. Here R is -2. We cannot say -2 is less than 1. I'll apply the sum till infinity. Sum till infinity will not even exist because it'll blow up. 24 minus 48 will be a huge negative number. Plus 96 will be a huge positive number. I mean, not huge yet in
No,
this
but
case.
in this kind of a thing, you can never find the sum, no?
Yeah, exactly. When
Because
R
it'll
is
go till infinity.
correct, when R is numerically more than 1, be it positive or negative, you cannot find sum till infinity. But if R is constrained between -1 and 1, we can
Approach
find the
zero.
sum till infinity. Okay, so let's do one practice problem, right? So we have Rohan here, and then let's say Avinash here, right? So Rohan initially has, let's say, fine, okay, I'll make up something. It's 300, right? And Avinash has 0. So they play a game where first day, Rohan will give half of his amount, right? So he'll give 150 to him. So he'll have 150. So this is, okay, fine. This is day 1, day 2, day 3. This guy will give back half of, right? So this guy will have 150 plus 75, 225. Okay. Now this guy will give not half of his, he won't give half of his wealth. He'll give half of the previous step. The previous step transaction was 150, right? And then 75. The next transaction will be half of 75. Maybe I should have picked up a better number, man. Okay, fine. Let's do 400. It's better, right? Fine. 400. Okay. So 400 and 0. So first day, 200 and 200. Second day, this guy gives 100. Therefore, it's 300 and 100. Okay. So, and then now he gives 250 and 150 and so on. You guys get the pattern, right? Now, my question is, suppose we do this for 1 year. 1 year in this case to be read as infinity, right? You will see soon for yourself that it'll converge. If you do this for a long time, like 1 year or something, how much wealth will Rohan have? How much wealth will Avinash have? Can you guys calculate this?
So can you repeat what you're doing in this?
In fact, I'll ask someone else to repeat. Apurva, why don't you repeat the question for Kunal? And where is your video on, Apurva? Why is your video not on? Yeah.
So I had gone to use the washroom, so I was not there.
Okay. But did you understand the question or you were not there?
Not, so I wasn't there.
Okay. All right. Rohan, why don't you describe the question?
Okay, so there's two people. One starts with 400 coins, the other starts with 0. The first person has to give half his coins to the other person. And then in the next round, he gives half of what he gave the previous round to the other person. And that cycle repeats until it converges to one answer.
Does it make sense? Right? So first day, Rohan gives 200 coins. Second day, Avinash gives 100 coins. Third day, Rohan gives 50 coins. And the next day, he'll receive 25 coins and so on. Right?
Okay.
At the end of this process, I mean, the process won't end, but after a long time, they'll stabilize in some value. Because the number of coins exchanged will be, no, don't say coins because coins is like discrete, right? So just imagine like some amount of money that can be infinitely divided.
So you're asking what will be the money left with both of them?
Correct, with each of them, correct. And a good check is collectively they should have only 400 because there's no other person in the system. You can check this, right? On any day, between them, they should have a collective total of 400. Sana, you're around? The video's off. You're okay doing this? Okay.
So I have a question.
Yes.
So in this one, you say that it starts off with 0, right? So should I take A as 0 or in this thing, because then it won't work.
That's something for you to figure out. That's part of the question. Yeah. In the sense, it won't all be formula substitution. Use A, this is R, right? You'll have to figure out what to use.
So, but you said when will they have equal amount of money, right?
No.
No.
I'll say after 1 year, how much money will Rohan have? How much money will Avinash
Okay.
have?
And this happens each month,
Each day, whatever, right? Each day.
each day.
Yeah.
Okay.
Which is why I said after a year, because 365 transactions is a long time. By that time, things will stabilize. Because the money exchanged after that will be very minuscule. Because it's halving every day, right?
Yes.
Okay, any answer? Rohan, you have something?
No, sir.
Okay. Okay, how much time more, guys, before we start discussing? Bihan, anything?
No, sir, I'm stuck.
Okay, Kunsh.
So I'm just thinking how trying to figure out what A would be.
Okay, I'll give another 30 seconds and then we'll discuss.
So like how will it ever stabilize?
Because the amount of money that's being exchanged each day is reducing by 2, right?
Yeah.
And therefore, after a long time, you'll hardly exchange. He'll give you 1/1000th of a paise, and you'll give him back 1/2000th of a
Yeah,
paise.
but that's still money, right?
Yeah, but it'll stabilize, which is why if you go to less infinity, right? Approximately,
Yeah.
it'll stabilize, right?
So it will go to infinity.
You'll after infinite transactions, how much will you have?
Oh,
You don't.
after.
Yeah,
Okay.
that which is what S infinity means. But in reality, you don't even have to go to less infinity. Practically speaking, after maybe 100 transactions itself, it's meaningless. After that, it's as good as you have stabilized. Right? So, let's discuss. Okay, since we have given enough time, right? So let's say I go from Rohan's perspective. I'll look at wealth that Rohan has at the end of some n number of days. So initially he has 400. At the end of first day or whatever, at the beginning of second day, doesn't matter. He has lost 200. Therefore, his wealth, Rohan's wealth, right? Rohan's wealth started off with 400, and then it decreased by 200, then increased by 100, then decreased by 50. And this is your sum of n terms in a geometric progression. Do you guys agree now? Now are you able to see, Avinash, what's your A, what's your R and all that?
Yes.
Okay, now can you tell me the answer, guys?
So
So,
we
but I
think,
got
like,
this part, but I did not understand because you said 365. So you can't.
Okay.
That sum infinity rule that you said won't work for -2, right?
It is not -2, it's minus half.
Oh yeah.
Right.
Oh yeah, sir. Yes, sir.
So Avinash is sorted. Okay. Sorry, Kunal, you had a question or? Okay.
like we don't have, like we can take the sum up to like 100 numbers or something.
Fine. S infinity is what I want. Okay, fine. Forget 100, forget 365. Fine. This goes on till eternity, right? After.
Yeah.
zillions of years, how much money will Rohan have?
Yeah. But like it has to be an approximate value, right?
Yeah,
Yeah, okay.
okay. Anyone, Rohan, by now you should have an answer, right? What is
So
S infinity?
Rohan will have 800 upon 3.
Okay,
And
800 upon 3, okay.
yes, I'm just finding the other.
And 400 by 3.
Yeah, first check is these two should add up to 400.
Yes, sir.
They
Well,
do add up to 1200 by 3, which is 400. Let's check. This is A, which is 400. R is minus half. So yeah, indeed it's 400 by 3 by 2, which is 800 by 3. Right? And Avinash will have 400 by 3. Right?
Yes.
If you want to do Avinash separately, Avinash's wealth started off with 0, right? And then he gained by 200, lost 100, gained 50, lost 25, and so on. So I can ignore the 0 pretty much. I'll start my geometric progression here. So A by 1 minus R. So same thing, 200 upon 3 by 2, which is 400 by 3. Okay. All right. Okay, so that's arithmetic progression and geometric progression. Another classic example would be, suppose you have a ball that's bouncing, right? So you have a ball that you let go from a tall tower. Okay, this is a tower. Okay, and then the ball bounces down, and then every time it comes up, because of some elasticity, it comes up to only 80% of its height. Okay, let's say this tall tower has a height of, I don't know, I'm just making up something, 100 meters. Okay, so every time the ball bounces, it'll rise up to 80% of its height. So the ball will go like this, like this, like this, like this, right? Forget the horizontal move that the ball has. That's just for illustration. Just assume the ball is just vertically traveling. I'm just for illustration, I'm showing it like this. So what is the total vertical distance the ball will travel after billions of bounces? Again, geometric progression, sum till infinity. Can you guys do this? Initial height is 100 meters, and the ball is dropped from the top of the tower. So there's one extra thing that you have to be careful here, which is why I'm giving this problem. There's one small catch, not a big one, but I'll let you guys figure it out.
So reduces by the it
So
becomes 0.8
every time-
of the previous one, right?
Correct. Every time it, so for example, after the first bounce, it will go up only to 80 meters.
And so what was the exact question you asked?
Yeah. What is the total vertical distance the ball will travel after millions of bounces?
So I'm
is it
assuming there's a
500?
catch, so I don't know what to do.
Sorry,
So I
sorry.
didn't find any catch, so
Even I didn't find any catch, so
Okay.
I'm still waiting.
Okay. All right. Tell me your answer, Rohan.
I got 500.
Yeah.
You 500. Both of you got 500. Okay.
Is it because it's not exactly vertical, it's a curve?
No, not that catch. So I don't know. I haven't worked it out yet. Let me do that with you. So the first travel is vertical only. After that, every travel is vertical and horizontal. And I mean, the first one is just downwards. After that, everything will be in a pair. 80 will be going up and 80 will be coming down. 64 will be going up and
okay.
right. So the
Yeah.
first one
Oh.
alone has to be counted separately. Right. That's the extra
Oh,
catch. Otherwise,
then I still
okay. So anyway, let's complete this. So that was the only catch, right? So either you can do it in two ways. Either I can keep this 100 separate. Okay. And then I'll start my geometric progression from here onwards. I'll say 2 times 80 plus 64 plus whatever the next one is, point times 0.8, 51.2, right? 64 into 8 is 512 and so on, right? This is sum till infinity. So it'll be 2 times.
So I got it 900. That's the answer.
Yeah.
Okay.
900.
Yeah. Okay. So this is 2 times 80 by 1 minus 0.8, which is 800. And then plus this 100, which has to be added, right? So the first bounce is only going downwards, right? There's no traveling upwards. That's the only catch. That's an important one. I'm sure there'll be answers for 900 and 1000 if this question came in the paper. Okay. Apurva, you're all good so far? Okay. All right. So let's move on to like basic number theory. Number theory is nothing but you should know your prime factorization. That's the main thing, right? The prime factor. Some of you might have seen this already. So just a quick recap, right? So any number can be prime factorized. So let's say I have a number like 360. If you have to prime factorize, try to divide it up into big chunks. Don't start with 2 times 180 and then 2 times 90. That will be waste of time, right? Go with bigger chunks of numbers like 18 and 20, as close as possible to each other. And then you can divide this as 6 and 3, this is 4 and 5. So you'll see that you'll progress to the end much faster this way. So 3 and 2, and this is just 3, right? So this is just 5. There's nothing, right? The leaf node is 2 power 3 into 3 power 2 into 5 power 1, right? The main advantage of prime factorization is you can count the number of factors very easily, right? So suppose I want to find, I'm not interested in listing all the factors. I only want to count the factors. How many factors does 360 have? Then it becomes very easy. So how does it become easy? So I have the prime factorization is this, right? So that means I have a basket of 3 2s. I have a basket of 2 3s. I have a basket of just 1 5. Now, to form any factor of this number, what do I have to do? I have to go to each basket and pick a few from each. Let's say I pick 1 2 and I pick no 3 at all. That's also an option. And I pick 1 5. The product of this gives me a factor, namely this is 10 is a factor. On the other hand, on another day, I can pick all the 3 2s and 1 3 and no 5. That's 8 times 3, which is 24. That's a factor. On another day, I can pick 0 from all the baskets. I'm not picking anything at all, which is 1, which is a factor. On a fourth day, I can pick all of the 2s, all of the 3s, all of the 5s. That's 360 itself. The number is a factor of itself. So like this, the number of factors is very easily got by the number of choices I have when I visit each basket. So when I visit the 2 basket, I can pick either 0 2s or 1 2 or 2 2s or 3 2s. I have 4 choices. Why do I have 4 choices? Because the power of 2 is 3, right? And because I start from 0, I could pick 0, 1, 2, or 3. Therefore, it's 4 choices. Similarly, here I have 3 choices, right? I could pick 0 3s or 1 3 or 2 3, 0 5s or 1 5. So the number of factors is just you add 1 to each of them, right? So it's 4, 1 to each of these powers. So the number of factors is just 4 times 3 times 2, which is 24 factors, right? So if I have any prime factorization, so for example, let's say P is a prime. So let's say I split a number n as P power A times Q power B times R power C times S power D, where P, Q, R, S are all prime, right? Then the number of factors, I'll just call it F of n, number of factors of n will just be A plus 1 times B plus 1 times C plus 1 and so on, times D plus 1. For example, let's say D is 0, right? Let's say this is 2 power 13 times 3 power 10 times 5 power 20 times 7 power 0 times 11 power 10, right? When it comes to 7 power 0, this will be 0 plus 1. So as if it does not matter at all, because when you multiply by 1, it's not going to change. So it's not like just because it's 7 does not appear at all, we have to do something special. No, we don't have to do anything. If 7 does not come in the prime factorization, the power of 7 will be 0. And when you count the number of factors, it'll be multiplying by 0 plus 1, which is as good as not multiplying at all. Does it make sense? Okay. All right. So let's do another example. So let's say I have a big number. Let's say I have 16. Okay, I'll just come up with another number. Let's say 16, 49, 25. Okay, fine. Let's say, okay, 16,000. Okay, 16,000 has a lot of factors that we all know. Okay, now I'm going to ask you, how many of these factors will be perfect squares? So how many factors are perfect squares? For example, 1 is a perfect square. 1,600 is a perfect square. So like this guy has many factors. 100 is another factor, which is a perfect square. 16 is another example. Like this, there are many, right? How many is the question? Can you guys work it out? Okay, Anahat, any idea so far? Your video is off, beta.
Oh, my bad. Oh, 1 second. I'm just finishing.
Okay. Sana, you're following along so far, even though you might not have done some of these
So I'm
homework
getting
questions.
4.
4. Okay. Okay, Vihan, noted. Sana, you're following along, right? All good.
Yes, even I got 4 right now, but I don't know if there are more.
Okay. All right. Sorry, I'm just talking to Sana. Just 1 second. Sana, I'm not able to hear you too well, beta. Are you following along well?
Yes, sir, but
You-
I'm not getting a logical answer for this.
Okay. Yeah, I keep telling you the same thing. So go back and practice, even though for class discussion, you might not have
Sure.
got some of this. I know finding time is hard, but just go back and review and try to do it on your own after
Yes,
class.
sir.
Please do that, please.
Yes.
Okay. All right. Only 4 factors, is it?
No,
Uh,
sir.
I got
so I
8.
thought 4, but it's
So
not.
I got 8 as well.
Okay. 8, 4. Okay.
Wait, I've realized a mistake. 1 second. Never mind.
Okay. So 8, is it? You have 8 as a final answer. Okay.
Yeah, so even I got 8.
Okay.
Yeah.
Let's check if it's 8 factors. Okay. So what is the prime factorization? So 16 is 2 power 4. And this is 1000. 1000 is nothing but 10 cubed. So that's 2 into 5 whole cube. So ultimately I have 2 power 7 times 5 power 3. Okay.
Yes.
Okay. So now, okay. Rohan, can you explain why it has 8 factors, 8 perfect squares, which are factors?
So if it's a perfect square, both the so 2 raised to x and 5 raised to y, both x and y have to be even.
Yeah.
So you can have 2 raised to 0, 2, 4, 6. There's 4 options. And you can have 5 raised to 0 and 2, which is 2 options.
Exactly.
And since 2 raised to 0 times 5 raised to 0 is 1, and 1 is a perfect square, it's fine. So 8 would be the answer, 4 times 2.
Okay. Yeah. Right. So well explained. Right. This is a basket of 2s. I can pick either 0 2s or 1 2, so 1 till 7 2s. This is a basket of 5s. Right. Now I can pick for this to be a perfect square. As you were saying, x must be an even number, y must be an even number. So I can only pick 0 2s or 2 2s or 4 2s or 6 2s. I have only 4 choices. Similarly, with 5s, I have only 0 5s or 2 5s. Okay. Therefore, the total number of perfect squares is 8. Okay. Now, same question. Let's extend it a little bit. How many factors are either perfect squares or perfect cubes? Yeah, Kunal, you have an answer?
So 14.
14 is a good wrong answer, meaning it's
Double
a
counting.
exactly.
Oh, yeah. Okay.
So is it 12?
Okay. 12. Okay.
I'm
Any-
also getting 12.
12. Okay. All right. Yes,
So-
indeed, it's 12, guys. Yeah. Apurva, you're saying something?
So I was getting 15.
How more than 14? Can you, Apurva, first explain how you get 15, please?
So because the factorization is 5 cube into 2 to 7, right?
Correct. Yes.
So I got like from 5 you can take 0, 2, and 3.
No, only 0 and 3, right? For perfect cube.
So did you
Okay.
ask?
Yeah. No. Well, so you mean either or, right? Okay, fine. Okay, fine. 0, 2, 3. Fine. Okay. All right.
And then from 2 to the power 7 you can take 0, 2, 3, 4, 6.
Okay.
And
Okay,
then 3 into 5.
Okay. This is also have double counting. Okay. I was counting double counting in a different way, right? So for example, oh, no. Okay. No, there's something more fundamentally wrong in this. Okay. So Apurva, please describe your process again. I'm going to ask someone else to find the mistake. Please describe exactly what you said one more time.
So since the prime factorization is 5 cube into 2 to the power 7,
Yes.
and you need to have either cubes or squares, what I
Yes.
did was I said you can take either multiples of 2 or either multiples of 3.
Yeah.
And so you can have from 5 you can take 0, 2, and 3.
Yeah.
And from 2 you can take 0, 2, 3, 4, and 6.
Okay. And therefore you did 5 times 3, which is 15. Okay. Now, question to everyone. This has double counting, that's for sure. But does every one of these 15 is a perfect square or a perfect cube? Rohan, you have your hand up.
Take the example of whatever 2 raised to 2 and 5 raised to 3. It's neither a
Exactly.
perfect square nor a perfect cube.
Exactly. Very good answer, right? If I have mix and match, then it's neither a square nor a cube. When you do 2 square times 5 cube.
So you need to count cubes and squares separately and subtract the ones that overlap.
Perfect. Exactly. And the mistake Kunal did was not subtracting the overlap. So yes. So if we consider only the cubes, the choices are only 0, 3, and 6 here. So 0, 3, and 6 here. And the choices are only 0 and 3. So which is 3 times 2, which is 6. So we have 8 at the top that we already did. And then we have 6, which is 14 so far. And the double counting is something which is both counted as a perfect square and perfect cube. We have to subtract. What are those? 0 and 6 here and just 0 here.
Yeah.
Right. So those are 2. So well done, Avinash. And whoever else got 12. I think Rohan, you also got 12. So 14 minus 2, which is 12. Okay, makes sense. Okay, I think we'll stop at this point. The only other thing I want to check was HCF and LCM, right? If I have prime factorization of 2 numbers, HCF is the minimum occurrence. Let's say I have 2 numbers. This is 2 power 3 into 5 power 2 into 7 power 10, right? And 11 power 3. And let's say this is A, right? And B is another number, which is 2 square times 3 square times 5 power 3 times 13 power 2. Then the HCF will be the minimum occurrence of each prime number. So 2 occurs minimum 2 times, 3 occurs minimum 0 times. Therefore, I won't include 3. 5 occurs minimum 2 times, 7, 11, and 13 do not occur in at least one of them. So the HCF just becomes this. LCM becomes the maximum occurrence. So 2 occurs 3 times, 3 occurs whatever 2 times, 5 occurs 3 times, and so on, right? 7 occurs 10 times. Okay, so on. You guys get the idea. So, and when you have 2 numbers, the product of HCF and LCM will be the product of the numbers itself. That you can prove very easily. Okay, let's continue from here on, right? And then maybe by next class, I want to finish the basics of permutation, combination, and probability. And then after that, we can start doing like topical questions, right? Okay, sounds good. Let's stop here. Bye. Good class.
Bye, sir. Thank you.
Answers.